So we're going to take x cubed plus 27. We're going to solve it. We're going to set it equal to 0. And you said if you put a negative 3 in for x, it's going to work. So x equal negative 3 is the root. So what if I solve this thing, set it equal to 0 on one side, x what equals 0? What do we put over here? Plus 3, right? You're going to add 3 to the other side. This is called a factor. What? It's that easy. You find the answer, that's the root, set it equal to x, and then solve for that equals 0. Now you've got a factor. That's all there is to the difference between a factor and a root. So what we would do next is we would say, what is x cubed plus 27 divided by x minus 3 and plus 3? And to divide that, you don't like this, do you? Long division. But you're going to get good at it. We're going to do this one right now. So we're going to put this big, the numerator goes in here. I call it the numerator. And then the denominator goes out here. So that's just going to be x plus 3. For long division, you do the same thing as if you went 27 sevenths. Okay, you would take 7 going into 27. The numerator goes here, 7 is here. Have you ever heard of this? Everybody hold up your right hand. And then think of this as a doorknob. Which way would you open the door? Turn your hand. Yeah, clockwise, right? This way? I call this turn the knob. If you turn this knob, the 27 falls into here, and the 7 is here. So if you want to remember it that way, you can. I saw that in an elementary book once. I thought it was awesome. 7 times what is 27 without going over? Can you get a 4 in there? No, but you can get a 3 in there. 7 times 3 is 21, right? What am I going to do with 27 and 21? What am I going to do with 21? Subtract it. So then it's 27 minus 21 is 6. And it isn't equal to 6. It has a remainder of 6, which we call 6 sevenths. So that 7 over 27 over 7 is the same as 3 and 6 sevenths. That's what long division does for us. We can do the same thing here. X times what is x squared? X times x squared. So you're going to get x times x squared is x cubed. 3 times x squared is 3x squared. Now, when I subtract these, what essentially happens to this 27 is the 27 gets moved way down here, plus 0x squared plus 0x plus 27. That's what happens to that. And then this is just going to be subtract, because we subtracted here, right? 21, you're going to subtract here. X cubed minus x cubed is 0. 0 minus 3 is negative 3x squared. If you want to, you can drop this 0x here. X times what is negative 3x squared? X times what? Negative 3x. Now you have x times negative 3x is that, but 3 times negative 3 is negative 9x. Whoops. Wait a minute. Wait a minute. Bring the 0x down here. Negative 3x squared minus 3 times 9 is 9x. Do what we did here. Subtract them. Take the opposite. So now you're going to get negative 3x squared plus 3x squared is 0. 0 plus 9x is 9x. Now, can you take x times something and get 9x? Yeah, you can. But remember, you have 27 here. to bring down. So x times what is 9x? Plus what? 9. So this will be 9x. 9 times 3 is 27. And when I subtract these, what do we end up with? 0. So what does that mean if it ends up being 0? It means that this is the factor, and these two are factors of each other. How could you find the factors of this? Well, you could try factoring it, or you could use quadratic. So that's easy to factor. So this is what I want you to be able to do. I want you to divide using long division, and you can use that using quadratic. So if you have a problem like this number 1 here, you're going to take x minus 3 and divide it into 4x squared plus 3x minus 1, and do that with long division. Your assignment for Monday is going to be to do these 4 and these total 7. I want you to do 2 of them with long division, and then the others, do you want to do the shortcut? Want to see the shortcut? This is synthetic division. Synthetic division is awesome. And let's do it this way. All right, first thing I'm going to do is I'm going to do this one with long division. I'm going to show you one more time long division. X minus 2 goes into x cubed plus 4x squared, 5x minus 14. Okay? You go x times x squared to get x cubed minus 2x squared. Subtract those, and you get 4x squared plus 2x squared is 6x squared. X times what is 6x squared? 6x. So you go 6 times x is 6x squared. Bring this thing down, negative 5x. 6x times negative 2 is negative 12x. Now you're going to add the opposite because they subtract. And you're going to get 12 minus 5 is 7x. Bring this thing down, right? Negative 14. X times what is 7x? Plus 7. And then you're going to get 7 times x minus 14. And when I subtract those, you get 0. Do you like it? Yeah, it's pretty good. But wouldn't it be great if you didn't have to do all of this writing? Wouldn't that be awesome? So here's synthetic, and it is going to parallel this perfectly. Here's what you do. Everybody draw a little box like this. Everybody, don't put your stuff away yet. And you're going to put the coefficients of the answer here. 1, 4, negative 5, 14. 1, 4, negative 5, and 14. These are the coefficients of x cubed, x squared, and so on. And you're going to look at x minus 2. Now, x minus 2 is the factor. What's the root? X equal to what? What's the root? 2. So if you have x minus 2, the root is x equal to 2. So the 2 is what we're going to be doing here. So once you get that, everything's going to be pretty systematic. Drop the 1. Then multiply 1 times 2 is 2. Add these 2, which is 6. Multiply these 2, which is 12. 2 times 6 is 12. 12 minus 5 is what? 7. What's 7 times 2? 14. Where did I miss here? Did I put a... Oh, this should be a negative 14. Whew. 14, and then when you add those up, you get 0. Now, if you get 0, This means it factors out. But here's what I want you to look at. This is the exponent of x squared, x to the first, x to the 0. So you get x squared plus 6x plus 7. Is that the same as what we have here? Yeah. And not only that, look at this. You're going to have this weird 2 here. That's here. This 12, that's here. This 14, that's here. Actually, down here. And so this method is just a way of getting rid of all of these extra steps. Now, this question people ask me all the time is, how come I subtract here and I don't subtract here? The reason you do that, you drop this first one, then you multiply, and then you add. That's how synthetic works. You drop, multiply, and add. The reason you don't subtract is because when I switched this from a factor to a root, notice this minus 2 turns into a positive 2. That's what makes it so nice. So when you go through the homework, and we'll look at remainder theorem on Monday, if you did this with synthetic, this very first one, you would go 4, 3, 1. What's the root? If x minus 3 is the factor, what's the root? X equal to 3. So you drop it, you multiply, and you add. Okay? Multiply and add. So what does this tell you? This is the what? That's the remainder, isn't it? So if that's the remainder, you're going to have x to the first, x to the 0. You're going to have x minus 3 times 4x plus 15, and you're going to have a remainder of 46. And it's actually 46 over x minus 3. Boom, boom, perfect. And have those 7 done for Monday.